Hello again, Crazy Logic's here. So off screen, we're in part 2 here. I have taken the time to take all the mica insulators and do the first round of cleaning. I filled this up with some rubbing alcohol and let it swirl around. It turned into what looked like milk, and then gently wiped them all off. They're real fragile. Be careful when you do that. Now they're ready for their second round of cleaning. So we're going to go ahead and soak them. Get them soaking. I've cleaned off the back of the fets pretty good. I went ahead and hooked up power, and we got the scope ready. We'll put it up on the screen, except that's going to block where we're working here. So we're going to be focusing on the drive over here of these fets. And so we've got some power hooked up. We're also going to be watching to see if this light comes on. We've taken the definite blown fet and the other fet that might have been damaged out. Here they are. And I found my silver marker also while I was getting prepped here. We're going to need to take some new fets and bend them to match. I got these flat cheapo pliers. They don't got no grip or nothing on them, but they are excellent for coming in. Match up your fet. See about where the bend needs to go. Get it all square. That looks pretty good. Maybe unbend it just a little. Just about right where we need to be on those fets. Alright, let's get the scope out. And we're going to probe right here on this drive resistor. Oh, and we're looking for the green light to come on. Hey, there it came on. Get in contact with the probe. Hey, there's a drive. That don't look half bad. That one don't look half bad. This one's got a little slope to it. This one's got a little slopage to it. So now we're going to make sure nothing's getting hot. On output section, one finger. Never touch, you can touch these backs and stuff for heat, but if you go 2 fingers and you happen to catch the positive and negative and there's a charge on these rail caps, on bigger amps and certain amps, there could be a lot of voltage there. You'll whoop, get a bite and it could hurt you or damage something. So always be careful. I always one finger all that stuff on the higher voltage side. Just be careful. Same thing on the rectifier diodes here, because this is a dual power supply. We got one here with a pair of rectifiers, one here with a pair of rectifiers. One other thing I did while I was prepping and looking is I got my flat edge out and looked at these caps, and this one is swollen, and this one's got a little swell to it, and this one's got the tiniest. This one doesn't have any. So I'm going to replace these 4 caps just because they've when this went, it must have got a little surge or from use or something. These 2 were fine, and I looked over the board at all the little ones. I don't see anything else swollen. I don't think there's any other damage anywhere. We'll have to get to the output section when we do, but hopefully these are good enough that we can test this with it, and then I'll show you how to unsolder them, get them out of there, especially if I don't think there's any glue on these, but get them out of there, and then I'll replace these for the final thing before I put it all back together. I don't have any right now, so I'll have to order them, so hopefully these will be good enough to let us get a test in, and then before I button this back up 100% in the heat sink, I'll replace those, and then this thing will be ready to go back into service. So our drive looked a little funny on the 2 transistors here. Remember, we got a pair here and a pair here for each one. That's the same for here. It's a pair and a pair driving this one. So let's go over here and look at this one's drive. It's going to be right here on the edge. And we'll see the power light come back on. And there's the drive waves building. So that don't look like absolute perfect, but it's not bad. And the way I got my power supply hooked up, and this is important, I got ground coming from my power supply. I got positive, and the positive has a maximum of a 10 amp fuse. We're on a test bench. We're not trying to do load testing or anything. So there's a 10 amp fuse in line here. And then my remote goes through from the power through a foot switch here. And the reason why I use a foot switch as turn on and turn off is it keeps both my hands free. And that way I can be taking measurements and doing stuff, and I can power it up, and if something goes wrong or something gets hot, I can let off the foot switch and power shuts down. So real important. So we watch that drive build on the scope there again up in the corner, and it's not perfect, but it's pretty close to these. Now on this good side that seems to be good, we can build up the drive wave. Here it comes, and then we can look at the center leg, which is going to be the output, or it's actually the back of these FETs in the middle. So we can look at that, and looky there, that looks perfect coming out. And really that's what you want to know, and that's what you're looking for on the FETs. Let's go ahead and so here's what the drive wave feeding the FET looks like, and here's what it is coming out. And it dang near goes to the top of the screen there, you see, but it's nice and perfect. So let's go over here again, and we're going to look at this one. And it's got about the same looking drive wave. Let's look at the back of the FET, and ooh, that does not look all that good. That's falling off real sharp. Let's go back to this thing. Here's the drive. Here's the back of the FET, and see how that drops off there? It's not a square. It's not nice like this other side. So we might have an issue with these two FETs. They're not getting hot while I've got it on. And as long as you're not running a signal or anything through it, don't have any load hooked up. If everything's functional, you don't have bad components, and I'm always feeling for heat, nothing should get hot just setting it idle. There is some exceptions to that. This amp does not have them on it. It must do it somewhere else in here. But a lot of times you'll have transistors that look like these that'll be there, and they're actually not transistors, they're voltage regulators. One will do plus and one will do minus, somewhere between 14 to 18 volts, and that is for the plus and minus volts and the for the op amps in the audio input section over here. And those can get hot just sitting there, because they normally do a lot of work, especially if the voltage feeding them is a little bit high, and they like to be clamped down to the heatsink. One thing you can do is take your heat sinks here and set them one all insulated, if you had that sticking out here, and tape it down when that's attached on the board to give you some heat sink room if those happen to get hot. You can do other things to clamp it on. Just be careful not to short nothing out. So these two don't look perfect. Oh, and now would actually be a fantastic time. Let's put our multimeter. I'm going to turn that right where you guys can see it. We're going to put the negative on the negative leg here. We'll get on volts, 20 volt setting on this multimeter. And we're just going to look at the drive voltage as it comes up. Bam, on this good side. And we're at about 4.4 volts when it's all together. Let's look at it over here. It's about 4.4 volts. So, not knowing anything, if you're just using a multimeter, you can tell if you got about the right voltage going to it, but you're not going to see those details like we've seen the bad wave off these without an oscilloscope. And you know, they're selling some cheap little digital oscilloscopes that look kind of like a tablet now. They come with a little kit, and they come with a probe that's got a pair of alligator clips. And they're selling them for like $39.99 or 40 bucks. You can buy a little case for them, and by the time you get the case and then you buy a real oscope probe, you're looking at upwards of $70 or so. And the reason why you got to buy a O-scope probe for those to even think about working in this is because they have a 50-volt max. And so with their probes don't do anything, but with a real O-scope probe, you got a 1-time setting, which you normally are using, but you got a 10-time setting, and you can flick that back to the 10 times and expand your voltage range. That puts a whole lot more resistance in here, and that will allow those little cheapo scopes to work. I've not tested one. I'd like to test one maybe one of these days, but once you're up into $70 or so, you're kind of looking at the used market for an oscilloscope like mine. I think with shipping, mine was super cheap. It's not the best oscilloscope, but it works. And you can buy a not top of the line old analog oscilloscope for that. Sometimes on eBay and stuff. You gotta be careful, make sure they're working. But so I'd rather go with the old scope. So I think we need to take these out. And so I'm going to kill power. And find my little resistor. I like to go ahead and drain this. Now, these rail caps can hold the rail voltage up, since we did have the power supply in and the diodes. So you can either try to go in between the legs on the diodes, or you can actually go, since these are metal, you can go on the back side with your resistor and drain these suckers down. Or when you flip it over, you can see where the caps are, and you can just touch there and get this drained down. Now, if you don't know, put your multimeter on there. Now I'm reading 0.06 volts, so we've already got drained. Of course, I knew I'd drained them by touching the rectifiers. But that's important to get that drained down before you do any soldering or anything else. So you can always check it with your multimeter to make sure that's down, and that way you save yourself from getting a zap. So we're going to take these other two FETs out, and since I bent up a couple of good ones, we will see about sticking a good one in this bank and a good one in this bank that we've already got out. But let's get these out. And on this bank, we'll put it in this spot, because this is the one that's got the broken trace that we still need to repair. All right. Let's see about dropping this puppy out. Just drops right out. Once you get it hot, if you've done it right, it'll just fall out. If it doesn't want to fall out, that may mean it has burrs. If it's got burrs, oh, I'm having trouble because my solder flowed in through the hole somehow there. Oh, it fell out. Yeah, okay. So let's go ahead and clean these holes up. There's a secret to using these, and that's getting silicone to go around this. It does a whole lot better, and I haven't got any silicone yet. The only thing I found is it's a big expensive roll for an outrageous amount, and you just need a tiny bit. So I'm still looking to make my desoldering tool a little better than what it is. Alright, hopefully these have cooled down. So these, we'll set these right here. Those are the two we thought were good. Maybe not, because of the signal we had. These are the two new ones we're going to be putting in. This is the one that was with the bad one, and that is the bad one. So we're going to have that there. So we're going to try this with one good brand new one in each, and then we're going to see what our drive looks like. Our stuff. So we're going to get the soldering iron out here. Get a little solder on there. Hold this flat so it'll get right. Get one leg and just hold it. Notice how that holds it in nice. Oh, I'm going to need to. These had solder blobs. Yeah, right there. The way this amp was designed, they like to put a solder blob on each of the legs. Clean that up a little. There we go. Notice we got a little solder came out. We don't want that anywhere near the back side of the board. Get this off and out of our way here. And we should be able to poke that up through the holes. And get a little solder on our soldering iron. Nice and level and even with the others. Just enough to hold it in. We can come back and do the middle leg. That's in nice. Or an outer leg. That gets that in nice. And we come back and finish this up. Now, anytime you solder or desolder, with places this close, if you don't flood the area with flux, once it's in, I want to put your meter back on continuity and test. Make sure that you don't get a dead short. That's called a solder bridge. And that's real important not to have a solder bridge because dead shorts are bad. All right. We have got more stuff here. I love this silicone mat for the heat resistance, but it's harder to clean off. Little stuff. All right. So, we're going to turn the power supply back on. Get our scope out. We're going to turn this thing on. We're going to watch this light, and then we're just going to leave it on for a second, turn it back off, and then we're going to feel these FETs and make sure they're not hot. Now, they're going to be a little warm here, so you kind of need to get a feeling of them from soldering them. But we're going to turn it on. It came on, no protection. We're going to let off. I don't feel anything crazy, so now we're going to watch the scope. That drive wave looks good. That one looks good. The scope is wigging out a little here. Now let's see what the drive wave looks like on the back here. A good drive wave, right? Yep. Uh-oh. Uh-oh. We got issues. We have issues. Oh, you know one thing I didn't check? Let's turn this off. I did not check to make sure we didn't have any shorts on this one. And looks okay. no shorts there. We would have probably not got okay on the thing, but that side is not happy. So, let's look at the drive wave here. We're about to come on. The scope is not like this cold weather. It throws it off in all kinds of ways. We'll wait for the light to come on. There it is, okay. We're driving into here. That's a bit fugly. And that is terrible. That is no good. That does not look like these over here. Whoa! These over here are completely wigged out and changed on us. Oh, my probe's touching. What have we done? The first thing I'm going to do is take this, make sure we didn't get any solder residue. I'll pick this up and out of the way. Make sure we're looking good here. A little alcohol. Paper towel. Just make sure we're picking up any bits of solder that might have been on there. I want to eliminate all the easy things. Well, we might have a drive circuit issue. Alright. So, we'll give this a good looking over. That all looks good. That all looks good. Back flipped over here. Let's look at this drive one more time. Comes the light. That looks terrible, 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 terrible. What's happening on this side? That does not look as good as what it did. The top is not flat, and you can see we are having pull down and pull up issues. And that is going to be in these little driver circuits here. So we'll shut this off. This right here is the drive board, and that is a TL494 chip right there. And it comes down and it's driving these little PNP transistors. And are they PNP? Sorry, they're the A105s. So let's see. Type it in. Is it 1015s or 10.5s? Sorry for the bald, fat, ugly head. Yeah, 1015. We'll do a quick Google and pull up the data sheet. It's a PNP. Yes, okay. So normally I can see there's 4 of them right here, and normally you get a PNP and NPN pair, and the NPN helps pull it back down and make that thing square. But I'm seeing right here that I got 4 transistors to drive this. This is part of the turn on circuitry and other checking. And so it's using a diode in here. I need a little pointer, don't I? There we go. It's using a diode right there and a pull down resistor set. And so something in there is not perfect. So we can take our probe, but I'm going to go ahead and put my protective cover on, because that is ground actually on this probe. Get my little trace out here. I'm going to fire this back up. I'm going to look on this transistor. That wave does not look good. That wave does not look good. Those transistors are not getting hot. And they looked good here just a second ago. So, those are Z44 V's. So I'm suspecting that one of those is not in very good shape, but it's somehow affecting the performance of this over here. So we only have one 144 chip, so if one of these is pulling bad, we can always check. Let's do this. This might be a 3-part video. We're having to do extra checks, but doing this for real instead of, you know, I try to set it up a little bit as far as making it go faster. But as far as getting down into the troubleshooting and stuff, I want you to see exactly what I have to go through. And you think you have the problem whipped, and you don't. You gotta find it. So it's checking at that one at 2.98, 3.7 volt. So it says that's kind of okay. Like there's nothing wrong with that. There may not have been anything wrong with that. I thought at first it was those pair of FETs making that ugly. 3.7 volt, that's pretty close. We can test a new one. .9, 3.5, so that's not bad. I got a funny feeling that's the problem there. So first thing we're going to do, make sure we're dead here, drain them caps out. Pull those transistors. So we look and see where they're at. And that is there and there. Go ahead and get this out of the way. Use my solder to hold that up a little. You guys see that? Soldering right there. Yeah, you'll be able to see that. Go ahead and find my tweezers again real quick. Look down underneath here. See if I can find where that sucker is. I'm going to need it to be tilted up a little more. There they are. See if I can get a hold of one. Get a light. The lights don't want to cooperate. There we go. Now I'll see that, and then it goes back out again. Kind of a booger and a bear to get to. I'm just going to see if I can gently. I want to put pressure really on those FETs. I need to be able to get in there, and that little transistors are just hidden by those coils so much. Get a little more solder on my soldering iron here. Gotta get a hold of this sucker again. There we go. Now, see, that, now it goes back out again. Kind of a booger and a bear to get to. I'm just going to see if I can find where that sucker is. I'm going to need to be able to get in there, and that little transistors are just hidden by those coils so much. Got one out. We'll clean them up once we get them out. Come on, work with me now. It's a little harder to do this and try to get camera angles and not get my big fat head in the way. So you guys can kind of see. I'll still get the parts out. All right. So we got those two little transistors out, and we'll test them on the tester. But first, we got to go through and clean up any mess we made with the soldering iron. We can always use a little solder wick. Make it a little better. If your solder wick's not doing a good job, add a little flux. Make sure there's no solder bridges. So I'll get out my magnifier here, because I'm old. You may have better eyes than me. Make sure that looks good. And then with the yield multimeter set to continuity, make sure there's no solder bridges. All right, no solder bridges. So we're already in at about 30 minutes. Holy crap, this is taking a lot longer than I planned on it taking. I figured this would be a quick job. We'll definitely have a part number 3, but let's fire this up. Now we've left the pull down stuff in, so it's okay to leave the FETs in. If you pull the drive transistors on a power supply, or if it's a FET outputs, which these are transistor outputs, the TIP 35s and 36s. But if you have the pull down resistors out of it, these things can float up and turn on and cause a dead short. So always leave your pull downs in, or take the FETs out of the side that you're going to power up. So we're going to go ahead and power up again here. We came on green. We're going to let off. Anytime I do something different, I feel for changes. So we can't measure anything on this side because those shouldn't be getting a gate drive at all. Oh, we are somehow. How are we still getting a... Oh, I wonder if this is shared. Between the two power supplies more than I was thinking, because that looks terrible. That's bad. That's still bad. Yeah, I wonder if I'm gonna have to look at the traces there. We may be sharing all of that more than I thought. I was figuring it was going to use one of each of these to drive each pair on and off, and they may be shared a little more in common than what I thought. Maybe I just don't feel any warmer. All right, let's go ahead and give these a little test and see what they come up, and then we'll call this quits. We've done a couple things troubleshooting this, and we'll just have to keep going at it. I am going to have to call it a night tonight and resume again tomorrow evening. I got to get up early and go to work. It shows up as a PNP, 220 and 622 millivolts. Ooh, don't know, well, I don't know if you can see that very well. There you go. That one. Test probe a little further up there. All thumbs tonight. I'm getting tired though. That's going to have to call it a night for tonight and resume tomorrow, and that's what you got to do sometimes. So we'll give that a test. Yeah, and see, that's not saying that's too awful bad. We may have to do some more pulling. And see what happens. My assumption is on the outputs here, since this is a 5-channel amp, that does 50 watts a channel, is probably got 1 channel, 2 channels, 3 channels, 4 channels, and then a double pair of them for the subwoofer. So whether that's 1 channel, 2 channel, 3 channel, I might even be able to tell. 35, 35. No, they're all evenly spaced out through here. We can do some probing and figure out which ones are in parallel for the sub out. But let's do one more thing. Get those little drive suckers out. Got our soldering iron here before I call it evening and we go back to troubleshooting tomorrow. Let's get a little solder on there. Go ahead and drop this back out. Drop that one back out. Suck up our solder mess. Checking for solder bridges here visually, and then we always test with the multimeter because it does better than our eyes, but I always like to give it a visual test. Sometimes you'll see a little flake of solder there and you can kind of flick it away and bam, everything will be good. They can be that small, that tiny. So we pulled all the FETs out over on this side. Let's go ahead and get some more juice going here. My oscilloscope needs a warmer environment, it says. It's so cold out in the garage. So let's go ahead and try powering it up. We're powered up. Let's look at the drive there. That looks pretty decent. That looks just god awful. So, with those FETs all out, we can try putting these transistors back in right here and see if this side straightens back out, because with nothing over here, this side ought to be fine. It looked pretty fine whenever we originally did it. So I think tomorrow when we go at this again, I'll do a little probing. We'll look at the back side of this circuit where those all are and see exactly how they're all interconnected. So that one transistor is slightly off from that other one. Okay, so So the other transistors are here and here. Pointer here. These three and these three. So we can either try putting that in, or we can pull these out and then look at the actual drive signal coming straight out of the TL494 pulse width modulation chip that's mounted on this board here. Right there. And see what that is. We'll figure out where it is. It should be pins 9 and 10. I use little cards, draw my spec up. I like putting them on a card instead of having them up on the computer screen, because the computer screen is hard to turn around. So depending on where that chip's mounted, you know, if it's mounted on the board, it could be this way or that way or whatever, however they designed it. So just to make sure I always got my pins right, I always throw this sucker over, you know, somewhere I can see it out of the way, but in the orientation that that chip is in, so I automatically can look at it and go, over here, yep, there's my VCC, I've got it labeled. I don't know if you can see all my chicken scratches, but I draw everything out on these so I can spin it around and have it orientated, so I quickly do it. A lot of people have them all memorized. I'm not a professional at this, it's a hobby, and so that's my way of taking care of that. Okay, I'm going to shut her down, and we will see you tomorrow evening as I do a little more of this. Thanks for watching. I hope this helps a little bit. We will get this sucker figured out. You know, leave a comment if you see something I missed. If you want a question answered, I'll try to answer it. The likes thing, that'd be fine. All that does is for YouTube's algorithm. The subscribes help if you want to, you know, grow bigger or whatever. There's not a huge audience for Amp Repair, but every little bit helps. And so if you like it, please comment, subscribe if you learned something. That's really what I'm doing it for. I appreciate it. Thanks, and I'll see you tomorrow night.